Hey guys, welcome. This is part 1 of our study guide, and let's get into it. Okay, so without graphing total to the point -1, 4 is a solution. So what we gotta know, this is our x comma y, and so we want to plug it into these equations to see if it's true. So instead of x and y, we are going to plug in the appropriate values of -1 and 4. So 3 times -1 is -3 plus 4. That becomes 1 equals 1, so that works. Now we got to try it in the other one. Instead of y, we're going to put parentheses, -2, parentheses, -4. And so this is -1, and then this is going to be +4. So this becomes +2 minus 4. That becomes -2 equals 4. That doesn't work, so no solution. It has to work for both, otherwise it's no solution. Okay? Solve each system by graphing. So our first one's already in graph ready form. This is y equals mx plus b. So our b is our y-intercept at 4, and then my slope is up 2 over 1, up 2 over 1, or down 2, back 1, down 2, back 1, so on and so forth. Let's just go and do some more. When you're graphing, you want to graph every point if you can, makes it a little bit easier. Over here, we're going to have to solve for its slope form, so subtract the 3x over plus 15, then divide by -5 to everything. So we get y equals, this is going to become 3/5 minus 3. So we're going to be at -3 here, and we're going to go up 3 over 5. 1, 2, 3, 4, 5. So if I keep going that way, it's not going to work. But if I go down 1, 2, 3, back 1, 2, 3, 4, 5, we're going to get our common point right there. And that's at -5, -6. I can plug that point in and it should work out for both. Solve each by substitution. Well, they both have y, which means I can just set them equal to each other. 2x plus 3 equals -x minus 9. I'm going to move this over and get 3x over here, and move that 3 to the other side and get -12. And then divide by 3, x equals -4. And then we're going to plug it into another one of the original equations. Instead of x, we can plug in -4. And we're going to get 2 times -4, which is -8, plus 3, which is y equals -5. So we get -4 comma -5. Okay. Solve each system of equations by substitution. Again, we can substitute this piece in for that y. So you get 6x plus 2 parentheses equals 8. And we can put -3x plus 5 in there. So we just substituted y for what y equals, which is that. You have to remember to distribute. So to distribute here, we're going to get 6x plus, that's going to be 2 times 3, which is -6x plus 10 equals 8. And what happens here is we're going to have 6x and -6x. They're going to cancel, and we get 10 equals 8. Unfortunately, that is not true, so this is actually no solution. These two lines will never meet, so they're probably parallel. Okay? Solve each system by elimination. So we're trying to go ahead and line things up and cancel them out. Right now, 3x and x won't cancel, -3 and 7 won't cancel. So what I'm going to do is I'm going to multiply this top by -3, so I get -3x plus 9y equals a positive 39. And now we can add these equations together. So 3x and -3x is going to go to 0. 7 plus 9 is going to give me 16y. And then 25 and 39 are going to give me 64. And then we're going to divide 64 by 16. We get y equals 4. Okay, so 4 is our back number. Then we got to plug it back into one of the original equations. I'm going to plug it into this bottom one. So we get 3x plus 7 times 4 equals 25. And then 7 times 4, I believe, is 28. 25 So subtract 28, we get 3x equals negative 3, and then x is going to equal negative 1. So negative 1 comma 4. Okay. Solve the system by elimination. Again, I'm going to go ahead and pick the top one and multiply it by a negative 5. That gives me negative 10x. Oh, I'm sorry, I did that wrong. I do not want to multiply negative 5. Oh, yeah, let's do it. Let's do that actually. Negative 40y and negative 30. And then this one I'm going to multiply by 2. And we're going to get 10x plus 40y equals 30. Negative 30. Okay. Well, what you can see here is if I add these equations, we're going to get negative 10. Oh, this is supposed to be a positive 2, so that's positive, and that's positive. Yeah, there we go. That's positive 2, sorry. So that cancels, and that cancels, so we get 0 equals 0. So basically, anything I plug in is going to work, so it's actually all real numbers. Or we can say infinite solutions. There's an infinite amount of solutions that will work for this. Charles bought 24 hockey tickets for $83. The adult tickets cost $5.50 and the child ticket cost $2. How many children's tickets did he buy? Well, we want to do a quantity equation and a cost equation. So I have adults plus children is going to equal 24 because there's 24 tickets. And then it's $5.50 for an adult plus it is $2 for a children's ticket, and that totals $83. Okay? So we can kind of quickly solve this by using a little bit of substitution. I'm going to go ahead and solve this for A. Down here I'm going to actually multiply all this by 10. So this is going to become 55A plus 20C equals 830. And it just makes it a little bit easier for me to solve. And then over here I'm going to go ahead and subtract the C, so we get A equals, it's going to be 24 minus C. So I'm going to take this guy right here and substitute it in for A. So we get 55 times 24 minus C plus 20C equals 830. So we get 55 times 24, that's 1320, minus 55C plus 20C equals 830. Okay, we're going to obviously run out of room here, so I'm going to have to get some more paper. I'm going to subtract 1320, and we're going to be left with 490, okay? And then these are going to subtract, and that's going to give me negative 35C. Okay, so let's come over here. Negative 35C equals 490, and then I'm going to divide. That's a negative 490, by the way, by 35, and hopefully we get a positive number, which we do, of 14. And if there's 24 tickets, then we just have to figure out how many adults. Well, 14 plus what gives me 24, and that's going to be 10. So we somehow managed to fit it all in, which is good. Okay. 8. Reed went to the movie theater, bought 2 popcorns, 3 drinks for $25.25. Michael went to the same movie theater, bought 4 popcorns and 2 drinks. How much does 1 drink cost? So we have 2 popcorns plus 3 drinks equals $25.25. And we have 4 popcorns plus 2 drinks equals $31.50. Okay? So if I multiply this top by negative 2, we can go ahead and cancel those. 4p minus 6d equals negative 50. Okay? So we can combine those cancel. That becomes negative 4d, and this becomes 3150 minus 50. So it's negative 19, and then we just divide it in. And again, we're trying to solve for how much 1 drink costs, which is exactly what we're doing. Divide by 4, and we're going to get 1 drink costs $4.75, which is insanely expensive. Hopefully it's good. All right, graph the inequality. So first thing we want to do is set this into y equals mx plus b form if we can. So I'm going to subtract the 2x. So we get negative 3y is less than negative 2x plus 6. Then divide by negative 3. Whenever you divide by a negative, remember the inequality sign is going to flip. This becomes 2 over 3x, and this becomes a negative 2. So we go to negative 2, and my graph is going to go up 2 over 3, up 2 over 1, 2, 3, so on and so forth, down 2, back 1, 2, 3, down 2, back 1, 2, 3. Okay, now it's dashed line. Okay, so I always like to write dashed because it's not an equals to, and it's greater, so we're going to shade above. Okay. All right, more graphing to come. X equals negative 3, so where is x equals negative 3? It's right here, and x always has to be equal, over here. Sorry, forget this spot, that was positive 3, it says negative 3. And it's an equal sign, so it's going to be a solid line. So solid, and it's got to be greater, so we got to go towards the greater numbers. Okay, so it's going to shade all this on this side. Okay, graph the linear equality, show all the possibilities. So we just have to graph each one of these. I'll do this one in blue. So we have negative 2 on the y, and then it's up 1, 2, 3, 1, 2, 3 over 1, up 1, 2, 3 over 1, down 1, 2, 3, back 1, 1, 2, 3, back 1. This is a dashed line. Sorry, that was not dashed very well, but it's dashed. Okay, and then we're going to do the next one, and then we'll do our highlighting after that. We're going to start at positive 3. My slope is down 1 over 1, so it's right down this kind of diagonal here. And it is a solid line. Okay. And, okay, so this one's going to shade up. This one's going to shade down. So our overlap region is going to be everything in here. Okay, so that's our overlap. Okay, this one, same thing, but we have to go ahead and solve. So I'm going to subtract the 2x. So negative y is greater than or equal to negative 2x plus 0, which doesn't mean anything. When we divide by the negative, the sign's going to flip. Okay, so we have to graph that. Then here I'm going to subtract the 3x over, and then we're going to graph that. So we start at 5. I'm going to go down 1, 2, 3 over 1, 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 up 1, 2, 3, back 1. And that is a dashed line, and it's shading below. This is going to be at 0. We have no y-intercept, but it's up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2, back 1, down 2, back 1, down 2, back 1, down 2, back 1. And this is a solid line, and it's less than, so we're going to shade. Whoops, sorry. This side, my bad. The overlapping region is going to be down here. I'm so sorry I messed that up. The red part's not supposed to be up there. All right. Okay. All right. This is an order of operations problem, so we can do the squared part first. That's going to be 16. These need to go together first because division happens before addition or subtraction. So that's going to be 8 minus, this is going to become negative 4 squared. We have to do square before we do the two negatives. We're going to get 16 plus 8 minus, that's going to become 16. And then we add them all together, and we're going to get our value of 8. Negative 3 to the 4th power, well, it's basically negative 3 times negative 3 times negative 3 times negative 3, which essentially you can just do in your calculator. So that's going to be 3 to the 4th power. you have an even amount, so it's going to stay positive. Okay? 5 to the negative second exponent, so that actually puts it underneath, and we get 5 squared like that, and then that's going to become 1 over 25. Anything to the 0 power is just 1. Okay, so now we get little fun ones. 3 and 27, that's going to reduce down to 1 over 9. X to the 0 is just 1. Y to the negative, I'm going to put that on the bottom as y to the 9th. And z to the negative 9, it's going to come up top, z to the 9th. So we're going to get basically z to the 9th over 9y to the 9th. Okay, zoom in a little bit more for this one, these ones. First I have to take care of the distributive property with this. This has become x to the 9th, y to the 24th. And then we're going to have x to the 6th, y to the 6th. Exponents are going to subtract, so I'm going to be left with x to the 3rd, and then y to the 18th power. And the bottoms are going to kind of disappear. Okay, before I distribute this 3, I'm going to try and reduce in here. X to the 6th and x squared are going to reduce, so that's going to be 4x to the 4th over y to the 9th. And then I'm going to do the 3rd power. So we're going to get 4 to the 3rd power, and then x, these are going to multiply to give me 12, and this is going to multiply to give me 27. And then 4 to the 3rd power is going to give me 64. So we get 64x to the 12th, y to the 27th. Again, we're going to distribute, so we get 5 to the 3rd, and then x, 3 times 7 is 21. And 5 to the 3rd power is going to give me 125, x to the 21st. All right. This is to the 3rd power, so we're going to get 2 to the 3rd, x to the 12th, y to the 9th. And then that's going to multiply 10 times x squared and y. When you multiply, they're going to add, so that's going to be x to the 12th plus x to the 2nd, which is x to the 14th. 9 plus, this is technically a 1, so we get y to the 10th. And then 2 to the 3rd is 8, and then 10, so we're going to get 80. First things here, I see it's negative, so this is going to flip like that, and then to the 4th power. So we're going to get 4 to the 4th and 3 to the 4th. And 4 to the 4th is going to give me 256, and 3 to the 4th is going to give me 81. So you got to be careful about flipping it because of the negative. Number 23, this can be broken down to 3 and 9, and then 3 and 3. We have 3 equal factors, and since this is a cube root, we're looking to pull 3 out, so we just get 3 out as our answer. Square root, we have 2 and 9, 3 and 3, so I get to pull a 3 out. Here you can divide these by 2. This is basically x to the 4th and x to the 4th. Here you could break that one into x squared, and y squared times y1. So we could pull out a y squared. We'd be left over with a 2 on the inside and a y. This we could rewrite as the cube root of 64 plus the square root of 36. The square root of 36 is 6. And then the cube root of 64, well, it's 8 times 8, but then we can kind of break that even further down. But the cube root is going to be, 1 second. You can always plug in your calculator and see what you get, but I believe we're going to get 8 times 8, and then that is 4 times 2, and 4 times 2, and then 2 times 2 times 2 times 2, so we get those 2's and those 2's, so 2 sets of 2's out, which is basically going to give us 4. So we get 4 plus 6, which is 10. This one, 16 3/4 is going to be 16 to the 4th power, but then it's cubed inside. Okay, so what we can do here is 1, evaluate this, and then break it down. If you have a calculator, sometimes it's easier just to go ahead and try that first. So if we did 16 raised to the, let's see, 3 over 4th power, we should end up with 8. Another way that we can kind of think about this or look at it is this is 8 times 2, and then if we had 16 times 16, which is basically to the 3rd power, we have 3 8s, and then 2 times 2 times 2 is actually another 8, and so that's why we get to pull 8 out, because there would be 4 equal 8s. Rationalize the denominator, so we just multiply the bottom by rad 7 over rad 7. So this becomes 6 rad 7 over 7. Okay? Alright, that's it for part 1.